Welcome to This Explainer. I am absolutely thrilled to have you here today because, listen, we are going to tackle something truly massive. I want you to think of today's session like a champion weightlifter stepping up to the bar for a world record clean and jerk, right? That weightlifter needs explosive power, perfect technique, and absolute razor-sharp focus for a short, intense burst of maximum effort. And you know what? That is exactly the kind of energy you need when you face those high-mark, complex questions on your Cambridge physics exams. Today, we're focusing on what I like to call the ultimate heavy lift in the 9702 syllabus: wave-particle duality and the electron diffraction evidence for the wave nature of particles. Honestly, this is the boss battle of A-level physics. It is notorious, it's incredibly tricky, and it catches so many students off guard. But don't worry, by the time we wrap up this explainer, you are going to have the exact structural strategy to lift those marks with perfect form. Okay, let's dive right into this.
So here is our game plan for today. First, we'll unpack the wave-particle challenge. Then we dive into examiner warnings and strategy. Third, we'll explore the transformation framework. Fourth, we are running a live interactive workshop to test your skills. And finally, we'll lock in the final exam system.
All right, Act 1, the wave-particle challenge. We are breaking down the absolute hardest physics questions you will face on the paper. Let's get into it. So, why do students find multi-stage analysis and method marks so incredibly hard? Seriously, this is the core anxiety for thousands of candidates across syllabus 0625, 0651, 0652, 5054, and most critically, the advanced 9702 A-level paper. You know the feeling, right? You turn the page in the exam hall, and suddenly you are staring at this massive, blank, 6-mark chasm. Your heart rate spikes, the timer is ticking away loudly in the background. Multi-stage analysis is absolutely terrifying because it's not just about knowing a single isolated fact. Oh no, it is about threading a needle through multiple abstract concepts, linking different formulas together, and structuring a flawless, logical argument from start to finish. If you drop the thread at step 1, the whole sweater unravels and you lose the marks. But today, we are going to change how you view these questions entirely. We are turning that panic into pure, focused execution. But before we talk pure exam strategy, we absolutely must lock in the physics itself: wave-particle duality. It is the concept that every single particle or quantum entity may be described as either a particle or a wave, which is beautifully evidenced by electron diffraction. Now think about this. We are so used to thinking of electrons as these little solid billiard balls of negative charge, right? Just tiny specks of matter. But here's where the universe gets wonderfully weird. When you fire a beam of electrons through an incredibly thin slice of graphite, they don't just bounce off like solid balls hitting a wall. Instead, they pass right through the atomic spacing of the carbon atoms. And those carbon atoms act exactly like tiny diffraction gratings. The electrons form concentric, glowing interference rings on a fluorescent screen. Literally, solid particles acting like ripples spreading out in a pond. It's mind-blowing. The momentum of the electron actually determines its wavelength. That's a direct mathematical relationship established by the de Broglie equation. Mastering this requires a profound shift in your conceptual understanding because you are combining classical mechanics with totally bizarre quantum phenomena. Now, to understand how to win those top marks, we first need to see exactly how students lose them. Let's analyze two very common student archetypes. First up, we have Alex. Now, Alex is basically a human textbook. For a 6-mark question on electron diffraction, Alex goes into overdrive and writes a massive, sprawling paragraph dumping every raw physics fact imaginable onto the page. De Broglie equation? Check. Photons? Check. The photoelectric effect, just in case it's relevant? Check. But here's the fatal flaw. Alex completely fails to analyze the specific data given in the prompt. There is no analysis going on, just a desperate information dump. Then on the other side, we have Sam. Sam is a sprinter. Sam sees a complex question, immediately panics about the time remaining, and just rushes. The command word clearly says evaluate, but Sam just describes the setup. Sam quickly calculates a wavelength, but completely forgets to link that number back to the actual spacing of the graphite atoms. The examiner reads both of these answers, sighs, picks up their red pen, and gives them both a tiny fraction of the marks. They did a lot of work for basically zero reward. We absolutely cannot be Alex, and we cannot be Sam. Which brings us to Act 2, Examiner Warnings and Strategy. We are going straight inside the principal examiner reports to see exactly what they are looking for and what makes them tick. Let's break down the top 3 fatal errors straight from the Cambridge examiners themselves. You really want to pay attention here. First bullet. Students confuse cause and effect in duality questions. This is huge. A student will confidently write that the concentric rings cause the electrons to act like waves. No, that is entirely backward. The wave nature of the electrons interacting with the crystalline structure of the graphite causes the diffraction pattern, which we subsequently see as rings. The cause and effect must be logically, rigorously sequenced. Second bullet, forgetting to check format and presentation conventions. I literally cannot tell you how many marks are lost every single year because a totally brilliant calculation is left without standard form, or it's missing its SI units, or it's presented to an absolutely absurd number of significant figures. Format is non-negotiable, folks. Third bullet, answers are not specific to the context given. If the exam question asks about an electron accelerated through specifically 4,000 volts in a specific vacuum tube, your answer cannot just be a generic textbook definition of duality. You must explicitly reference those 4,000 volts and show the examiner exactly how that specific voltage affects kinetic energy and momentum.
The severity of this issue is summarized perfectly in this rather sobering quote directly from the examiner reports. They wrote, "Wave-particle duality, electron diffraction evidence for wave nature of particles, is one of the most misunderstood areas in physics." Let that sink in for a second. The examiners actually know you find this hard. They are practically expecting you to stumble and fall here. But think about what that means for you. This means if you can produce a structured, analytical, and context-specific answer, you immediately separate yourself from the vast majority of candidates taking that paper. You elevate your response to the top tier. You turn that expectation of failure into your ultimate advantage.
To truly excel in these exams, you have to shift your mindset completely. Excelling isn't about rote memorization. It's about treating every single question as an opportunity to demonstrate clear, logical physics communication. Before we subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's talk about your ultimate safety net in the exam hall, the method mark strategy. Look at the left side here. A wrong final answer with no working shown equals absolute zero. It is a complete waste of your time and your effort. You gave the examiner absolutely nothing to work with. Now look at the right. A wrong final answer, but with clear, systematic working shown, you get method marks. Let's say you're under pressure, your hands are sweating, and you accidentally mess up squaring the velocity in your kinetic energy calculation. It happens. But if the examiner can plainly see your formula, see your substituted values, and follow your clear logic step by step, they will award you marks for the process. You might actually get 3 out of 4 marks for a mathematically incorrect final answer, purely because your underlying physics logic was sound and, most importantly, visible. Never, ever hide your thinking. Your working out is your insurance policy. Write it down. Moving into Act 3, the transformation framework. It is time to learn how to actively turn that red examiner ink into brilliant green check marks. Okay, this framework right here builds into an operational checklist. This is the standardized sequence you must run through in your head for every complex problem you face. Step 1, identify key elements. Extract the data from the text. What is the accelerating voltage? What is the mass of an electron? Get it all laid out. Step 2, apply relevant principles. If you have moving electrons, that means electric potential energy is being converted to kinetic energy. Then you apply de Broglie's relation, linking that momentum to the wavelength. Step 3, execute analysis with clear working. Write the formulas out explicitly, substitute the numbers clearly step by step. Step 4, verify results. Now this is where top students shine. Does a wavelength of 10 to the power of -11 meters make sense for an electron? Yes, actually, it's roughly the atomic spacing of the graphite. Perfect. But if you did the math and got 3 meters, you'd immediately know you made a massive mistake somewhere. Step 5, present an appropriate format. Double-check your significant figures and your units. Follow this exact 5-step checklist, and I promise you, your answers will be basically bulletproof. When you hit a seemingly impossible question in the exam hall, you need to literally stop your mind from scrolling through a panic-induced list of random facts. Stop, breathe, and trust the process. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome to Act 4, the interactive workshop. It's time to put your knowledge to the test right now. Get your mental gears turning because I want you treating this next part exactly like the real exam environment. Imagine a 60-second timer is ticking down. First, we need to decode the examiner's brain. Assessment objectives in Cambridge physics target 3 distinct cognitive domains, and you need to hit all of them. First up is knowledge. This is the baseline. Do you understand the core principles? Can you define the de Broglie wavelength from memory? That's your basic recall. Second is application. Can you transfer those core concepts to completely unfamiliar contexts? Say the exam gives you a brand new, strange-looking electron gun setup that you've never seen in your textbook. Can you still confidently apply the same kinetic energy physics to it? Third, and this is the absolute top tier, analysis. Can you evaluate alternatives and justify them with hard evidence? For instance, if the accelerating voltage in the experiment is doubled, how precisely does the diffraction ring diameter change on the screen, and logically, why? To get the maximum 6 marks on these tough duality questions, your analytical paragraphs must hit all 3 of these domains simultaneously. You can't just rely on knowledge. So, to guarantee we hit all those domains, we use the ultimate problem-solving sequence: deconstruct, solve, evaluate. And to write this out perfectly under immense time pressure, you need the PEEL framework. That stands for point, evidence, explanation, link. Let me show you how a perfect answer flows. Make your point. Increasing the voltage decreases the diffraction ring diameter. Great. Now provide the evidence. Electric potential energy equals kinetic energy, so the kinetic energy of the electrons increases. Now give the explanation. Higher velocity means greater momentum, which, according to de Broglie's equation, results in a shorter wavelength, hence less diffraction. Finally, link it all back to the question. Therefore, the interference rings compress inward on the screen. Boom, perfect marks. I have a challenge for you. The next time you sit down to do a past paper, set a 30-second timer on your phone and force yourself to speed write your analytical paragraphs using that exact PEEL structure. It is a complete game changer for your exam performance. Now, to make all of this complex theory actually stick in your brain, we use a memory hack, the visual story method. Look, physics isn't just dry math on a piece of paper. It's literally the story of how the universe operates. To encode wave-particle duality, I want you to close your eyes and visualize the incredible story of the electron. See it boiling violently off a glowing hot tungsten cathode. See it being ripped away and accelerated across a vacuum by thousands of volts, gaining massive, terrifying momentum. See it flying toward and slamming into the incredibly tight, perfectly ordered crystalline lattice of the carbon atoms in the graphite screen. And then, at that magical, incomprehensible quantum moment, see it squeeze through the atomic gaps, not as a tiny solid particle, but washing through as a wave of probability, interfering with itself to paint beautiful, glowing green concentric rings on the phosphor screen. If you can vividly visualize that entire story from start to finish, you will never, ever forget the sequence of the physics.
Act 5, the final exam system. We are bringing everything we've talked about together into one cohesive blueprint to ensure you can secure top marks consistently, paper after paper. Here is your complete cheat sheet recap. These are the 3 golden rules that will save you. First, command word decoding. Are they asking you to state, describe, explain, or evaluate? You must treat those words like binding legal contracts. Give the examiner exactly what they ask for, no more, and certainly no less. Second, PEEL framework application. Point, evidence, explanation, link. Use this to build structured, unassailable, highly logical arguments that examiners basically have to give full marks to. Third, and this is so critical, the time management matrix. In any Cambridge exam, marks equal minutes, period. Do not spend 10 precious minutes writing a beautifully crafted essay for a simple 2-mark question. And conversely, do not rush a massive 6-mark data analysis in 60 seconds just because you're panicking. Manage your explosive energy perfectly, just like our champion weightlifter from the beginning of the explainer. The most crucial takeaway today is this. Top-scoring candidates demonstrate evaluative thinking by questioning assumptions, considering different perspectives, and justifying their decisions with rock-solid evidence. They don't just calculate blindly, they interpret the reality behind the numbers. They don't just write down memorized facts, they build a compelling case. When you approach the 9702 wave-particle duality questions with this elevated mindset, you aren't just trying to survive the exam, you are dominating it. When you truly start to understand wave-particle duality, you aren't just memorizing facts to hit a target grade. You are acknowledging that the fundamental building blocks of our reality behave in ways that completely defy everyday logic. If solid matter, like an electron, can actually act like a ripple in a pond, what other assumptions about the universe are we taking for granted? Let that profound question drive your curiosity forward.
Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.